Hello everyone, this video is regarding JEE Mains past year questions on the chapter Limits, Continuity and Differentiability Part 1. So the first question for this video. Limit x tends to 0 root 1 minus cos 2x by root 2x is, options are 1, minus 1, 0, does not exist. So first, how will we proceed with this one? First we will apply a basic trigonometric identity, which is 1 minus cos 2x is nothing but 1 minus 2 sin square x, right? So if you substitute that here, 1 minus 2 sin square x divided by root 2x. So for the simplification, what you will get, limit x tends to 0 root 2 sin square x divided by root 2x. So this is nothing but limit x tends to 0 mod sin x by x. We know that in case of a mod function, left hand limit and right hand limit will not be same, so the limit of this value does not exist. The final answer for this question is the limit does not exist for this question. So moving on to the next question. Limit x tends to infinity, x square plus 5x by 3 5x plus 3 divided by x square plus x plus 3 whole power x. The options are e power 4, e square, e cube and 1. So how will we proceed with this sum? First, initially we should write, we can split the numerator as x square plus x plus 3 plus what else is remaining, 4x plus 1 divided by x square plus x plus 3 whole power x. So this can be rewritten as, if you split this separately, limit x tends to infinity 1 plus 4x plus 1 by x square plus x plus 3 whole power x. Then for further rewriting, what you'll get, limit, if you see this, you can multiply and divide by, if you multiply and divide by the power. So we'll write in next step, limit x tends to 0 1 plus 4x plus 1 by x square plus x plus 2 x plus 3 whole power x square plus x plus 2 by 4x plus 1 whole power. There is a x over here, so x into 4x plus 1 by x square plus x plus 3. So what we are doing, we are just multiplying means we are multiplying a by b and we are multiplying b by a whole power. So this will effectively be the same thing. But why are we doing this? We know that limit x tends to infinity 1 plus lambda x whole power 1 by x is nothing but e power lambda. So if you observe this formula can be this step can be written as e power limit x tends to infinity 4x square plus x. This is, if you consider this as lambda and x, what you will get, 1 plus lambda x whole power 1 by x. This can be written as, we have x over here, so 4x square plus x divided by x square plus x plus 3. So further what you can do, it is an a infinity, 0 by 0 form or infinity by infinity form, so we can apply L'Hospital rule, and further if you simplify this limit, you will get e power 4. So the final answer for this question is e power 4. So moving on to the next question. Let f of x is equal to 4 and f dash of x is equal to 4. Then limit x tends to 2 x into f of 2 minus 2 into f of x by x minus 2 is given by, options are 2, minus 2, minus 4 and 3. So if you substitute the function value directly here, what you will get 0 by 0 form. So we can directly apply L'Hospital rule. What is L'Hospital rule? We should differentiate the numerator and denominator until the 0 by 0 form is eliminated or 1 by 0 form is eliminated. So if you apply L'Hospital rule, what you will get, first part, if you apply, it will become f of 2 minus, this part is 2 into f dash of x. This denominator, if you apply L'Hospital rule, it is just d by dx of x minus 2, which is 1. So if you apply this, now if you apply the limit, what you will get, f of 2 minus 2 into f dash of 2. So what you will get, f of 2 is nothing but 4 minus 2 into 4, we will get 4 minus 8, which is minus 4. So the final answer for this question is minus 4. So moving on to the next question. We have limit n tends to infinity 1 power p plus 2 power p plus 3 power p plus and so on n power p divided by n power p plus 1. Then the value is, options are 1 by p plus 1, 1 by 1 minus p, 1 by p minus 1 by p minus 1, 1 by p plus 2. So how will you proceed with this sum? Limit n tends to infinity sigma r is equal to 1 to n. This can be written as r is equal to 1 to n power p by n power b, n r power p by n power p into n. So you can write this part is nothing but n power p into n, right? Numerator can be rewritten as, if you consider r is equal to 1 to n sigma, I am writing in the form of summation. So this can be further extended as limit this can be rewritten as sigma integral 0 to 1 x power p dx, which is nothing but x power p plus 1 by p plus 1 from 0 to 1. So if you substitute the value here, 1 by p plus 1 minus 1 by 0, which will be 1 by 1, which will give 1 by p plus 1. So the final answer for this question is 1 by p plus 1. Moving on to the next question. Limit x tends to 0 log x power n minus step of x, n belongs to n, where step of x denotes the greatest integer less than or equal to x, has the value minus 1, has value 0, has value 1, does not exist. So if you observe this, limit x tends to 0, step of x never exists, right? So the given limit does not exist. So the final answer for this question is the given limit does not exist. So moving on to the next question. If f of 1 is equal to 1 and f dash of 1 is equal to 2, then limit x tends to 1 root of f of x minus 1 by root x minus 1 is, options are 2, 4, 1 and half. This is a similar question which we done in the previous 2 or 3 sums back. So how will you proceed with this sum? You should observe the 1. If you substitute 1 here, what you'll get, denominator is 0 and numerator is also 0. So what you should do, you should apply L'Hopital rule. What is the L'Hopital rule? Until this part is eliminated, I mean this 0 by 0 form is eliminated, you should apply derivative on upper and means numerator and denominator. So if you apply the derivative on numerator, what you'll get, 1 by 2 root f of x into f dash of x minus this part is 0, so divided by, if you apply L'Hopital rule below, 1 by 2 root x. So if you substitute 0 now, this implies limit x tends to 0, f dash of 1 by 2 gets cancelled, root x into root f of x, so root of f of x. So this is nothing but, if you substitute 1 value now, the limit value x tends to 1, limit value if you substitute, you will get 1 f dash of 1 is 2, f of 1 is 1. So final answer for this question is 2. So moving on to the next question. If f is defined in minus 5 comma 5 closed interval as f of x is equal to x if x is a rational number, minus x if x is a irrational number, then f of x is continuous at every x except 0, f of x is discontinuous at every x except 0, f of x is continuous everywhere, f of x is discontinuous everywhere. So if you consider this sum, for a limit to exist, what you should say, if for a limit to exist, the LHL should be equal to RHL should be equal to the limit value at that point. So if you observe this, what they give, x is a rational number for if f of x is equal to x, if x is a rational number, f of x is equal to minus x if x is irrational number. If you consider in this interval, if you observe, the left hand limit and right hand limit will not be same for, is different for all the values except for 0. If you take the 0 value, if you take x is equal to 0, the left hand limit will tends to 0 and right hand limit also will tends to 0. So f of x is discontinuous at every x except 0. At x is equal to 0 only, the left hand limit and right hand limit will be equal to 0 and the limit value also will be equal to 0. So the final answer for this question is f of x is discontinuous at every x except x is equal to 0. So moving on to the next question. F of x is equal to f of x and g of x are two differential functions on 0, 2 such that f double dash of x minus g double dash of x is equal to 0. F dash of 1 is equal to 2 into g dash of 1 is equal to 4 into f of 2 is equal to 3 into g of 2 is equal to 9. Then f of x minus g of x at x is equal to 3 by 2 is, options are 0, 2, 10 and 5. So how will you proceed with this sum? Initially they give f double dash of x minus g double dash of x is equal to 0. So if you integrate, what you will get, f dash of x minus g dash of x, you will have an integrating constant which is c. So if you substitute 1 here, what you will get, f dash of 1 minus g dash of 1 is equal to c, implies if f dash of 1 is we know that 2 g dash of f1 is equal to f dash of 1. From that what you'll get, this implies 4 minus 2 is equal to, from simplifying from this, 4 minus 2 is equal to c implies c is equal to 2. So what you got, f dash of x minus g dash of x is equal to 2. Now if you integrate this, f dash of x minus g dash of x is equal to 2, what you'll get, f of x minus g of x is equal to 2x plus c, some other constant c1. So now if you substitute f of 2 minus g of 2, f of 2 minus g of 2 is equal to, if you substitute the value, 2 into 2 plus c1. So from this what you'll get, f of 2 minus g of 2 is nothing but f of 2 minus 9 minus 3 is equal to 4 plus c1. So 6 minus 4 is equal to c1 implies c1 is equal to 2. So f of 2 minus, you got f dash of x. So f of x, similarly if you write f of x minus g of x, this value must be equal to 2x plus 1 c1, right? So if you substitute f of 2 and g of 2, you got the value. So from this you got c1 value, which implies f of x minus g of x is nothing but 2x plus 2. So we want f of x minus g of x at x is equal to 3 by 2. If you substitute that f of x means x is equal to 3 by 2, if you substitute, what you'll get, 2 into 3 by 2 plus 2, which gives 3 plus 2, which is 5. So the final answer for this question is 5. So moving on to the next question, f of x plus f of y, f of x plus y is equal to f of x and f of y, and f of y is equal to 2, f dash of 0 is equal to 3, then f dash of 5 is, options are 0, 1, 6 and 2. So how will we proceed with this sum? So first take f of x plus y is equal to f of x into f of y. So if you differentiate with respect to x initially, what you'll get, f dash of x plus y is equal to f dash of x. We are differentiating with respect to x and taking y as constant. So f dash of x plus y is equal to f dash of x into y. Now if you put x is equal to 0, what you'll get, f dash of y is equal to f dash of 0 into f of y. So f dash of 0 is nothing but 3 into f of y, correct? So what we want, f dash of 5. If you substitute y is equal to 5, what you'll get, 3 into f of y. So f of y is nothing but 5, nothing but 2. So 3 into 2, 6. So the final answer for this question is 6. So with this we conclude the first part of our video. We'll get back to you with the second part. Thank you.